Looking at these two, this is a system. How do I know?
Because X by itself.
What?
How do I know it's a system? It is a system. How do I know?
Because
There is no X by itself. Y'all are just making up stuff. Y is not by itself. Can you look and tell me what you see?
Numbers.
Two equations.
Oh, please, you go.
There are two or more equations.
There are two or more equations, which make it a system. This particular system, is it ready for substitution?
No.
Why?
Because it doesn't.
Because there's not a variable by itself. There's another way to do it. It's called elimination. Better that than I call your name out in the video, right?
Do it.
You want me to?
Do it.
Okay, Shelley, you might want to stay with me. Here we go. Step one. This is just a little different than substitution. We're going to write them, and when we write them, we want to line up our variables. Stop grumbling. Yours should look like mine. Your equal sign will be lined up. It all looks real pretty. Neatly done. Ready? This one is set up for elimination. Why? Do you see something that's going to eliminate when I combine these? The Y's are going to wipe out, aren't they? We're going to take this and we're going to do it just like if we were adding up and down. How many X's am I ending up with? 2X and 2 X's? 4X. When I combine my Y's, how many Y's are we going to have? We got no Y's, which means we eliminated it. Look, hence the term elimination. When I combine my constants, 12. Funny thing about combining these constants is some people just tend to forget and they just put the 4. Is that going to get you to a right answer? No, pay attention to what you're doing. So now we got to solve. So I am currently set up with what? 4x equals 12. So x equals 3.
Wait, how'd you get rid of the y?
Because it says 0y. What's 0 times y? 0. So it like goes away. It got eliminated. From this point forward, it's just like yesterday. We take the x equals 3 and we substitute it back into one of our original equations to solve for y. Which one would you like to put it in?
The positive.
The second one. So 2, it's an x, so 2 parentheses plus y equals 4. I put parentheses for the x because we're going to replace the x with what it equals. X equals 3. So we got a 3. So 2 times 3 is 6 plus y equals 4. So what does y equal?
1.
Oh, come on, let's do better at math than that. There you go, negative 2. Good joke. I laughed inside. We're going to write our point, being very careful to put it in x, y order. Yep.
How did you get negative 2?
Because I subtracted 6 from both sides, so I had 4 minus 6, which is negative 2. We want to check it. To check it, we can't use that equation. We got to use the other one. So let's see. We'll write 2 parentheses minus parentheses equals 8. All I did was write this, but instead of putting the x and y, I put parentheses because I'm going to plug in my point, right? My point is 3 for x, negative 2 for y. 6, what's negative 2? Positive 2 equals 8. 6 plus 2? 8. So I got 8 equals 8. True statement? That is our answer. We did awesome. Let's try another. This is our next system. Is it set up for substitution or elimination? Elimination. There's not a variable by itself. So we're going to go ahead and write it, lining up both of our, variables. X plus 4y equals 8. 2x minus 5y equals 29. If you combine all your x's, how many x's will you have? 3. If you combine all your y's, how many y's will you have? That's not good. We didn't get a 0. So this is what's going to happen. We're going to have this special number that we're going to multiply by. Because we want to either get rid of the x's or the y's. Which one, just looking at them, do you think would be easier to get rid of, the x's or the y's? I agree. I think the x's. This x is 2x. What do I have to combine with 2x to get 0x? Negative 2. They have to have the same number, but different signs, right, to get 0? So we're going to take our first equation up here and multiply it by
2.
negative 2. If I do that, I get negative 2x. Got to be very careful in these steps, because if you make one mistake, then, it's just downhill after that. Negative 2 times 4y is
Negative 8y.
Okay. And then negative 2 times 8. Don't forget that one. Negative 16. The other one I'm not going to change. We thought it was fine the way it was. So 2x minus 5y equals 29. Now look at your x's. Will they go away?
Yes.
Notice to make them go away, you need the same number, but different signs. One's got to be positive and one's got to be negative. So let's go ahead and combine. How many x's do I get? 0. So I'm not even going to write that. Negative 8 and negative 5 is?
Negative 13.
So I got negative 13y equals negative 16 and positive 29?
Is
13. And if I solve for y, what do I get?
Negative 1.
Y equals negative 1. So that's the new stuff. The other stuff is all old. I'm going to take it and I'm going to plug it in. Never, never, never plug it into this, the thing you changed. Always go back and plug it into one of your original equations. So, which one do we want to plug into?
The first x.
The x plus 4y. I've got a y, so I'm going to leave a blank for my y. So I got x plus 4, parentheses, equals 8. What will I put in my parentheses where the y was?
Negative 1.
Negative 1. So on the left, do you agree I'd have x minus 4 equals 8?
yes.
So x equals,
12. Negative 4.
add 4 to both sides.
12.
It's x minus 4, add 4 to both sides, and you get 12. Being careful, write these in order x, y. I got 12, negative 1. Don't write them in the order you got them. Write them in x, y order. We're going to check. We got to check with the other one. The other one would be 2, parentheses, minus 5, parentheses, equals 29. Plug in your 12 and your negative 1. What's 2 times 12? 24. And negative 5 times negative 1?
5.
Positive 5. 24 and 5?
29.
Does 29 equal 29?
Yes.
So, yay, this is our answer. That is where our two lines would intersect on a graph. That is the solution. How many more solutions will we find?
None.
None. Lines will only intersect at one point. What are the other possibilities where lines may intersect? If it's not one point, then it could be every point. And if it's not every point, it could be no points. Let's practice some more. This one's a little more challenging. Notice I got a number in front of both my x's, a number in front of both my y's, and they're all different. It's a lot easier when you get one that's like blank, like this one, right? Because then y could just multiply that by -3. This one's a little more challenging. What do you think would be easier to eliminate, the x or the y?
The Y.
The x, what number should we turn the x's into? 6. So that means I want a 6x and a -6x. Do you agree? That's the only way I'm going to get 0. Yeah? So we're going to take this first equation and I have to take that 3x and turn it into 6x. How am I going to do that? Multiply by 2. So I got 2 times 3x, which is 6x. I already wrote that. 2 times 5y. 2 times -16. Nice job. Second scenario. I'm going to change colors. This time I want to get -6x.
You have to.
-3. Notice how all you did was swap those numbers when you multiplied, right? But they were both positive, so one of them had to become negative. So I got -3 times 2x gave me -6. I got -3 times 3y. I got -3 times -9. What happens to my x's? They cancel out. One is positive, one is negative. They become 0. How many y's do I get?
1.
Oh, isn't that nice? So y equals what? What? See? Did what she just do.
-5. Wait a minute.
-5. Sometimes we think we're done, but we're really not. We're looking for a point. So now I got to take that -5 and plug it back into one of my original equations, not either one of these. Which one you want, the 3x or the 2x?
2x.
Okay, so that gives me 2x plus 3 parentheses equals -9. What do I put in my parentheses? Very good. 3 times -5 is,
-15.
okay, then what would I do? Add 15 to both sides, and I get 2x equals 6. Now what would I do? Divide both sides by 2, and I get x equals 3. We've got an x and a y. We're going to carefully write them as a point in the right order. At this point, we could go on to the next problem and not check it, and not know if we got it right, or we can make sure we got it right so we don't lose any points. What do you think we're going to do? Yes, we are. But we can't use the same equation. We can't use the 2, 3. We're going to have to use the 3, 5 one. So I got 3, 5, and -16, correct? Take my point and plug it in. 3 times 3 is 5 and -5. What's 9 minus 25?
-16.
Does -16 equal -16? Yes, which means that is our answer. We did good. Don't you wish it always worked out that way when you're on your own?
I do.
Yeah.
Dang it. It should be harder with the teacher and easier on your own. Why does it have to be the other way? Looking at the next one, is it set up for substitution or elimination? Elimination. What do you recommend we do? Because as is, I would end up with 4x and 20y. That's no zeros.
You would multiply it.
What would I multiply?
The X.
3.
The first one by. Okay, I'm going to do what you said.
Negative.
Oh no.
Thank you. -3x. Will my x's eliminate? Yes. There you go. -3 times 5y.
Negative 15.
And then I got -3 times 4. Okie doke. My x is eliminated. How many y's do I have?
Zero.
Uh-oh.
Yeah.
Oh wait, 1. Oh wait,
0.
0.
How many constants do I have? Combine -1, -12, what do we get?
-13.
Does 0 equal -13?
No.
I have a false statement, and I lost my variable. What could that possibly mean?
Parallel.
They are parallel lines. So talk to me about my answer. What's my answer then? You have no solution. Anytime you get that, you lose your variable, you got to tell me. You're either going to give me an answer of no solution or infinitely many. You got to decide which one it is, okay? These will never equal each other, so no solution. They will always equal each other. Oh, that would be infinitely many. By the way, I think we got a typo. This is supposed to be an 18. Change that, please. Looking at that, is it set up for elimination or substitution? Elimination. So as I look at it, I'd get 15x and 9y, which means nothing became 0. So what would you recommend? -2.
What?
Oh, I'm okay with -2. Anybody have another idea? You could multiply the top by -2. You could also divide the bottom by -2, couldn't you? That would give you smaller numbers. Anyway, we got -10x, -6y, and -36.
Wait a minute.
Zero.
Ah, nicely said. We end up with 0 equals 0. We lost our variable and we have a true statement. So we got a true statement and we lost our variable. So what does that mean?
They are
Infinite.
Infinitely many. What type of lines am I talking about?
on top of the
Cut.
They're coinciding lines. So we got coinciding lines. And our solution would be infinitely many. Absolutely every single answer out there is a solution. To get our elimination, when it's not already ready to eliminate, we have that special number.
Wow.
That special number is going to cause your x terms or your y terms to be the blank, but with blank signs. What do you think?
same opposite.
We need the same number, but we need the signs to be opposite. So you're going to pick a number that you can multiply by that would create them to be the same, but one's positive, one's negative. Okay, looking at coins in my pocket. Let me give you a heads up. You see this? It's going to look just like that on the text. So you might want to pay attention. What are we putting in each box? What is she talking? It's going to look just like that, just different numbers. Okay? Looking at this, I got clue number 1. I have only nickels and quarters. Okay, so I got a certain number of nickels and a certain number of quarters. Yeah? Well, what kind of variables could we use for nickels and quarters?
N and Q.
Okay, so we'll let N be what?
Nickels.
Number of nickels, right?
Yeah.
Yeah, it wouldn't make much sense for that to be quarters. And then Q would be number of quarters. You don't have to write this down. I'm just writing it down for you so you can see it. Notice they've already got your graph labeled. So what is the independent? The nickels, right? Which means what's going to come first in my equation? The nickels or the quarters? Because it always goes AX plus BY equals C. Okay, clue number 2. I have 9 coins total. We have enough information to write one of our equations.
Equals 9.
Huh? What equals 9? N,
NX plus
NX.
N plus Q
equals 9.
The number of nickels plus the number of quarters equals 9 total coins. So N plus Q equals 9.
Okay.
Since it's a system, that means there's more information because we got to write 2 equations. This one talked about how many coins were in my pocket. The other one's probably going to be about how much they total money-wise. Clue number 3, the dollar value of the coins is $1.25. How would I write that?
Oh, $1.25.
$1.25 is $1.25. Well said. We're done. No. $1.25 is involved.
Wait.
Equals $1.
Okay, so we got equals $1.25. N plus Q. N represents the number of nickels. Q represents the number of quarters. What's a nickel worth? 5 cents. Wouldn't you if you were counting money and you were counting nickels? 5, 10, 15. So we could take 5 cents times our number of, that means we're dealing with decimals. Do you want to deal with decimals?
No.
So if I put something instead like every nickel is worth 5 cents, what do I need to do to this $1.25? Instead of doing $1.25, couldn't I just make it so many cents? And how many cents would that be? 125 cents. That makes it a whole lot easier, right? So I'm going to make my 2 to cover up my point there. So I got 5N plus,
25 Q.
because quarters are worth
25 cents.
25 cents. Let's get my Q there.
Here, who?
X-intercept. We're going to do the hand. If I cover it up, I got N equals Q. So what does that mean? N equals, I didn't say Q. I take that back. N equals 9. Means we go down here. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's my x-intercept? 9. So I'm going to write it. What does it mean?
It means that I have 9 nickels with 0 quarters.
I got 9 nickels and 0 quarters. I got 9 nickels and I got 0 quarters. If I could write. Next one. My y-intercept. Cover up that and I got Q equals 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my y-intercept. So what would I write?
9.
Very good. 0, 9. It's a silly thing to put 9, 0 there and lose points because you simply put them backwards. What does it mean?
It means that 0 nickels you got 9.
0 nickels and 9 quarters. Very carefully draw your line because if you don't do it carefully, you're not going to find the appropriate intersection. I'm going to go with a new color for my second graph. Once again, we're going to use the hand, and we got 5N equals 125, so N equals
15.
I've heard it a few times. 25. So that means I got an x-intercept of 25. What does it mean?
At 25 nickels. Wait, yeah.
25 nickels
You can have 0 quarters.
and 0 quarters. Using the hand again, I got 25Q equals 125. So Q equals 5. Got to remember this is a y-intercept, so I'm going to put 0, 5. What does it mean?
5 quarters and 0 nickels.
0 nickels and 5 quarters. Very carefully connect your dots and see where your intersection is. Oh, I did a horrible job connecting my, let's undo. Where did you have an intersection at?
5, 4. 5, 4.
Mine is not working out very pretty. I didn't do a very good job. 5, 4. Let's see. This goes right. Oh, it's because my orientation's off.
Uh-oh.
Uh-oh. Okay. I'll take your word for it. 5, 4.
You can't believe your student.
Well, I'm pretty sure that's what I had earlier. So it's crossing right there.
5, 4.
Okay, so what does 5, 4 mean?
5 nickels, 4 quarters.
5 nickels and 4 quarters is $1.25. You gotta include all of it. So 5 nickels and 4 quarters is $1.25 and
25 cents. Oh.
and what's the other part of the riddle?
With 9 cents.
9 coins.
With 9.
Okay, with 9 coins. I like it. Okay, so let's try another riddle. I got 7 coins, nickels and dimes this time. They got a value of 40 cents. How do we want to write it? One of them. Nickels and dimes, we could do N and D.
We're not doing 3 on this? Yes.
What is 3? Oh, what is the meaning of this point of the intersection in terms of the equations?
You can have
You got two, no. You got 2 equations. You graphed them, and there's that point. What does it mean? It's the intersection. It's the solution. Yeah, this is just in regard to the equations. It's not in regards to the story. So it's just the solution. I have 7 coins, only nickels and dimes this time. They total 40 cents. How many nickels and dimes do I have? So how would I write it? N plus, why am I doing Q? N plus D equals?
40.
Really?
No.
7 coins. Now what?
5N plus 10D
5N plus 10D
equals
equals 40 cents. Can we graph it? Doing the hand, I got what? N equals?
7.
Okay, 1, 2, 3, 4, 5, 6, 7. D equals? Isn't that nice? 1, 2, 3, 4, 5, 6, 7. Connect your points. New color. I got 5N equals 40, so N equals 8. 8's right there. I got 10D equals 40, so D equals, okay, 1, 2, 3, 4. Carefully connect your points. What do you get for a solution? What? 6 and 1? I'll take your word for it. Mine's a little off. What does it mean?
You have 6.
I got 6 nickels and 1 dime. Tell me more.
For a total of 40 cents.
For a total of 40 cents and
Using 7 coins.
with 7 coins. Okay? Last riddle. I have 7 coins. This time it's only quarters and dimes. How would we write that sentence? Q, right? So Q plus D equals 7. Number of coins. I'm not going to put the money until I put the money in front of the quarter and the dime. What's a quarter worth?
25.
So I got 25Q plus 10D equals 100 cents. So Q equals So 1, 2, 3, 4, 5, 6, 7. D equals
7.
1, 2, 3, 4, 5, 6, 7. Draw your line. 25Q equals 100. So Q equals 4. 1, 2, 3, 4. 10D equals 100. So D equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Carefully connect your points. What's your solution? 2. I got 2, 5. What does it mean? 2 quarters.
$5.
5 what? 5 times is how much? 100 cents or a dollar. With how many coins? 7 coins. Good job. Questions, problems?